Hey everyone, welcome back to Voltage Learning. Today we're solving a slightly trickier voltage divider problem. This one includes multiple parallel resistors at the output. So here's the setup. We have a 12-volt battery supplying a voltage divider. The top resistor, R1, is 2 kilo ohms. And finally, the parallel branch is R2, which is 4 kilo ohms, in parallel with a 3 ohm load resistor and another 6 kilo ohm resistor. Our goal is to find the new output voltage across this parallel network. So let's get into it. Step 1, find the equivalent resistance of R2, the load, and R3 all in parallel. The formula for parallel resistors is 1 over R equals the sum of 1 over each resistance. So 1 over 4 plus 1 over 3 plus 1 over 6. Adding those up, you get 9 over 12, which simplifies to 3/4. Now flip it to find the equivalent resistance. 4 divided by 3, or about 1.333 kilo ohms. Step 2, find the total resistance of the whole divider. Since R1 is in series with the parallel group, just add them. 2 kilo ohms plus 1.333 kilo ohms equals 3.333 kilo ohms. Step 3, use Ohm's law to find the total current. Current equals voltage divided by resistance. 12 volts divided by 3.333 kilo ohms gives about 3.6 milliamps of current. Step 4, calculate the voltage drop across the top resistor R1. Multiply current times resistance, 3.6 milliamps times 2 kilo ohms equals about 7.2 volts drops across R1. And finally, step 5, find the output voltage across the parallel network. Since the supply is 12 volts and we lose 7.2 volts across R1, the output voltage is 12 minus 7.2. That's 4.8 volts across the load, which is our final answer. And that's pretty much it. By combining parallel resistors, using Ohm's law, and applying simple voltage divider rules, we found that the output voltage across the parallel network is about 4.8 volts. If you want more problems like this or more practice, visit us at voltagelearning.com, and don't forget to like, comment, and subscribe for more circuits tutorials. Until next time, we'll see you guys later.